Hi, welcome to my video on find theta with the restricted domains. Restricted domains. Solve for theta with restricted domains. An example, solve for theta. A, sine theta is -1, and we're looking at the domain from a negative 180 degrees less than theta less than 0. So that means it has to be a negative angle, not a positive one. So sine is negative. Let's see where that would be. Add sugar to coffee. And sine is negative. Sine is positive in 1 and 2, so it's negative in 3 and 4. So we're looking at 3 and 4. But we're looking at from a negative 180 to 0. So negative 180 to 0, and sine is -1. But if we think about sine is -1, we're really thinking about the unit circle. Because when we say positive and negative, or negative ratios, we're thinking about like a half, √3/2, √2/2, etc. But sine is -1. Sine is the y. So what we're doing, we're thinking about where y is -1. So x is 0 and y is -1, and that's right here on the unit circle whose radius is 1. So that angle for theta would be 270 degrees. Positive. But if you think about theta as being a negative, then it's from a negative 180, from negative 180 to 0, that's right here. So 270 is the same as a negative 90. So theta is a negative 90 degrees. So if you do calculator and go sine of a negative 90 degrees, you'll get -1. Again, this is a restricted domain. You have to obey what the angles are in this domain. B, cos is a half, and we're going from, notice now that this is not degrees, this is radians. So cos is a half. So let's look at where cos is a half. Let's look at it right here. Add sugar to coffee. And cos is positive, so positive would be 1 and 4. So that's in quadrants 1 and 4. But the radiant measure is, where is this going from? Pi/2 is 180 divided by 2 is 90. So 3 pi over 2 is 270. 2 pi is 180, so that's 360. So we're looking at the radiant measure from 270 to 360. That means 270 to 360. 270 is right here, 360 is here. So we're looking at really a fourth quadrant angle. So we're looking at the fourth quadrant, where we got to draw the term alarm. And cos is a half, so we drop the perpendicular to the x-axis. Cos is the x, so the x is a half. That means the y is √3/2. The radius is 1, hypotenuse. So opposite the √3/2 is a 60-degree angle. So that means the reference angle is 60 degrees. So we want the angle 60. So that means we want theta to be all this distance here. So theta is 360 minus 60 degrees. So that means we have theta to be 300 degrees. But it's not in degrees. We want it in radians, between 3 pi/2 and 2 pi. So 300 degrees multiplied by pi over 180 to convert it. The zeros cancel by dividing by 10. 6 into 18 goes 3. 6 into 30 goes 5. So theta is 300 degrees. So theta is the same as 5 pi over 3. And just to notice the reference angle is 60. That means that in relation to radians, that's a pi over 3. 180 divided by 3 is 60. That means the angle that you're going to give in terms of a radian has to have a pi over 3. So pi over 3 is a 60. So 5 60s makes 300. So this is the radiant measure that fits where cos is a half. Now, again, I did the degrees and then I convert degrees to radian. You might find that better to do. C, sine is 0 from negative 270 to a negative 90. So let's see, sine is 0. Again, add sugar to coffee is only for when you have non-quadrantal angles. So sine is 0. We have to look at this one. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. This is the quadrantal angles for 0, 90, 180, 270, 360. So sine is 0. Sine is the y. So where is y 0? Y is 0. So that means we have 0. We have a 0 degrees. And we have 180 degrees. Sine is the y. So we got 0 degrees. And we got 180 degrees. But that's positive. But we want the negative rotation between negative 270. So this is negative 90, negative 180, negative 270. So we're between negative 270 and a negative 90. So it's in here that we want. So it has to be 0 is not right. So it has to be theta is 180 degrees is the one we're going to pick. But it has to be negative. So it has to be a negative 180. So the answer could be that 180 would be the positive one. But we want the negative one. So the answer is the negative 180 degrees. Again, the answer has to be between negative 270 and negative 90. So 180 won't do. 0 won't do. It didn't fit. So there's the answer. Negative 180. D, cos. Now we need a calculator. Cos theta is a negative 0.2, 0.2079. And so we have, because it's not a half, root 3 over 2, or root 2 over 2, 1 or 0, we have to use our calculator. And it has to be, the angle has to be between 180 and 360. So let's see, where is add sugar to coffee, because this is the decimal. So cos is negative, cos is positive in 1 and 4, so it's negative in 2 and 3. But it's quadrant 2 and quadrant 3. But we have to pick up the angle on the circle. The angle has to be between 180 and 360. So that's 90. So the angle theta we're talking about has to lie in here. So that's in quadrant 3 and 4. So which quadrant is mentioned here? 2 and 3. Which quadrant is here? 3 and 4. So it has to be the overlapping of quadrant 3. So let's draw the circle. And we're in quadrant 3. Right there. Perpendicular. So we have to use our calculator now. So turn on the calculator, clear it. So I have to use, make sure. So now I'm going to use this one right here. So I'm going to say cos of the reference angle is 0.2079. So the reference angle is cos to the negative 1 of 0.2079. So I'm going to use my calculator and go inverse cos to the negative 1 of 0.2079. And when I hit enter, I should have the reference angle to be 78 degrees. So move the calculator. 78 degrees is in the third quadrant. There's the reference angle of 78. So theta is this rotation here, right around. That's theta. So theta is 180 plus the reference angle. So that's 180 plus 78. And so that answer is 258. And if you check the cos of 258, you should get a negative decimal 2079 close to it. Just check it out. Okay, let's work on some more. Now, I showed you how that worked with the restrictions. Now, you can pause the video and work each of these out. Number 1, solve for theta. Cos is 0. Again, it's not a fraction, so we'll look at the circle. Cos is the x. So where's x? 0. X is 0 here and here. So x is, that's 0, 1, 0, negative 1. So that means, according to that theta right here is going to be at 90 and 270. That's in degrees, but this is in radians. So let's take 5 pi over 6 and convert it. Pi over 6 is 180 divided by 6, so that's 5 times 30. That's 150. And 5 pi over 3. So pi over 3 is 180 divided by 3 is 60. So that's 5 60s. So that's 300. So I need an angle between 150 and 300. So that means that theta 90 is not going to do it. So in degrees, the answer is 270. So I change that to a radian. So I will multiply that by pi over 180 and cancel. So theta, zeros cancel. 9 into 18 goes 2. 9 to 27 goes 3. So I have a 3 pi over 2. 3 pi over 2 is the radiant measure, because the restricted domain says it has to be between 5 pi over 6 and 5 pi over 3. And 3 pi over 2 will do it. So notice I worked it out in degrees first, found what the answer is, but I converted the radians to degrees to check what degree measure I had to go between. So between these two answers, 90 didn't do it. So this is the way I would work it out. But again, different teachers do different ways. Number 2, again, don't forget to pause your video. Sine is negative. Add sugar to coffee. Sine is negative. Positive in 1 and 2, so we're in 3 and 4. So we're in quadrants 3 and 4 here. So just write that down. According to this, we're in quadrants 3 and 4. But let's look at a negative 270. That's right here. Let's see. That's 0, negative 90, negative 180, negative 270. So that means you're between negative 270 and a negative 90. So that's here. So that's quadrant 2 and 3. Again, the common quadrant is 3. So the answer has to come out in quadrant 3. So if we draw the circle and we'll draw the terminal arm in quadrant 3, perpendicular to the x-axis, root 2 over 2 has got to be a 45 reference angle. So the reference angle is 45 degrees. And this is the third quadrant, and it's got to be negative now. Notice it's got to be between negative 270, so it has to be negative. So if it has to be negative, instead of going this way, I could say, well, that's 45. This is a 135. This is the negative one. So that means theta, if you think about it, is a negative 135. The reference angle is 45, and I need a negative angle between negative 270 and negative 90. So that means I have to go this way for theta. There it is. So that's a negative 135 multiplied by pi over 180. And I know it's going to be a pi over 4. Why? Because 45 is pi over 4. 180 divided by 4 is 45. Since the reference angle is 45, this is going to be a pi over 4. So how many 45s are in here? There's 3 of them. 3 45s makes 135, and it's a negative 3 pi over 4. Again, you can change this, cancel, divide by 5 and simplify this down. You will get 3 pi over 4 if you reduce this down. But I did it quicker, knowing that's 45. This is going to be a pi over 4. How many 45s will divide into here? 3, and it's negative. But you can reduce 135 over 80 down. Divide by 5, divide by 5. 5 into 180 is 36. 5 into is 27. 9 and that goes 3, 9 and that goes 4. So you get 3/4 pi negative. Now, how about the cos of a negative root 3 over 2? And again, notice this is in radians. So let's change. This is radiant. Pi is 180. That's 90. Pi divided by 2 is 180 divided by 2 is 90. So 3 times 90. So the angle we're looking for is between 180 and 270. 180 and 270. So 180 and 270. Let's see. 180 is here. That's 90, 180, 270. So that means, if we think about it, we're in quadrant 3. But let's check. This is in quadrant 3, no matter what I say here. So that means, but I'm just going to check further. Cos is the x, and the x is negative. Add sugar to coffee. And cos is negative and positive in 1 and 4, negative in 2 and 3. So this is 2 and 3 quadrant. This is between 180 and 270. 180 and 270 is got to be quadrant 3. So that's quadrant 3. So again, I'm in quadrant 3 because this is the angle between 180 and 270, no matter what this is saying. So I can't go to quadrant 2. And cos is the x. Cos is the x. So the x is negative root 3 over 2. And the y is a half, but is negative in this quadrant. That's a 1. So opposite of half is a 30. So I have a reference angle of 30 degrees. And the angle has to be between 180 and 270. So theta is, in the third quadrant, is 180 plus the reference angle. 180 plus 30 is the reference angle. So the angle is 210, but it has to be in radians. And a fast way, watch this, the reference angle is 30. So if the reference angle is 30, that's equivalent to, I got to be careful, pi divided by 6. 180 divided by 6 is 30. So that means this angle here, in terms of theta, is going to be pi over 6. But how many 30s are in 210? There's 7 of them. It's just a fast way to do it. The reference angle, whatever the radiant measure is, then the main angle in relation to theta is going to be a multiple of that pi over 6. And just to check, 110 degrees multiplied by pi over 180, and cancel the zeros. 6 into that goes, let's divide 3. 3 into 18 goes 6. 3 into 21 goes 7. So 7 pi over 6. And number 4, sine is decimal 6299. And we need from a negative 270 to 0. So a negative 270 to 0. So negative 270 is here. That's negative 90, negative 180, negative 270. So on my circle, I'm working from here to here. So I'm in quadrant 2, 3, and 4. But sine is positive, and sine is positive. Add sugar to coffee. And sine is positive in 1 and 2. So that's the y. And I'm in quadrants 1 and 2. So this is in quadrants 2, 3, and 4. Which one's repeated twice? So we're looking at the angle in quadrant 2. And it has to be negative. So we take up our calculator and we go, here we go. We're looking for the angle. So I turn my calculator on and clear it. So I have to go inverse sine of 0.6299. And so the reference angle is 39 degrees. So I have a reference angle of 39 degrees because I had to do the reference angle is sine to the negative 1 on 0.6299 that I plugged in the calculator. That come out to be 39 degrees. So I have a reference angle of 39 degrees and I'm in quadrant 2. So let's draw quadrant 2. There's quadrant 2, perpendicular to the x-axis. Reference angle is 39 degrees. Reference angle is between the terminal arm and the x-axis. So I need a degree. So if this is 39, then I can do it two ways. I can go this way and pick up what positive is and then go this way. Or I can say theta is a negative 180, subtract 39. So that would be a negative 219. Because I have to have an angle between negative 270 and 0. It has to be negative. I could have picked up the positive one and then subtract from 360 to get the negative. But if I'm going negative angle, I'm starting from here and going to there and going this way. Like that. So what's this? That's 180. That's 39. That's negative and that's negative. So it's a negative 219. This is the final answer. So that's working it out with what we call restricted domains. We have to obey. The answer has to come out of what this is saying. Again, this is in radians between pi and 3 pi over 2, and 7 pi over 6 is between that. Just to show you that pi, watch this, pi and 3 pi over 2. So this is a 6. 7 pi over 6 is in the middle. So this is 6 is your denominator. So pi is 6 pi over 6, the same as pi. And if I put a 6 here, 3 times 2 is 6, so that's 9 pi over 6. So 7 pi over 6 is in between. Pi is 6 over 6. 3 pi over 2 is 9 over 6. All denominators are 6. So 7 pi over 6 is between pi and 3 pi over 2 when you convert the same denominators. But I didn't do that. I'm explaining that way. I picked up the degree and then I converted my degree to a radian, which is probably a little bit easier. And that brings us to the end of this video. If you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.